This is part two. You can watch them in any order. It doesn't matter. I'm just doing a bunch of past paper questions. There is a sort of loose sort of categorization. The first part tended to be questions that involved substitution and integration by parts. So I'm going to try and find questions that aren't, that are a little bit different. So here's one where we have to do partial fractions first. So this is like a check to see um, how well you can do partial fractions. So, as always, please pause this video, have a go at the question, and then watch my worked solution. If you don't need the worked solution and you just need to look at the answer, you can use the chapters to fast forward to the point where I just provide the final answers. Okay, so for part A, we're going to do the write this as partial fractions. So in general, this is the equation that we're starting with. We're starting with saying that it can equal three separate fractions. And what we do in order to get from this stage to the stage where we can start doing things, we multiply both sides by this denominator. Now that gets rid of the denominator on the left-hand side. And if you look at the right-hand side, each of these fractions needs to be multiplied by that denominator. So one of the factors is going to cancel out in each of these three cases. So the left side of the equation, we just left with 4 minus 2x. And then at A, the 2x minus 1 cancels out. So we're just left with x plus 1, x plus 3. And for B, the x plus 1 cancels out. So we're left with 2x plus 1, x plus 3. And for C, the x plus 3 cancels out. So we're left with 2x plus 1, x plus 1. So now we choose values of x to make those disappear so we can work out A, B, and C. So let's make x equal to minus 1 first. So we've got 4 minus 2 times minus 1, so that's 6. The minus 1 makes that disappear and that disappear, so we're just left with the B. So we've got to sub minus 1 in here and in here. So this becomes B times minus 1 times 2 plus 1 is minus 1, and then minus 1 plus 3 is 2. So minus 2B equals 6. So B equals minus 3. Now we let x equal to minus 3. And that will make the brackets with x plus 3 disappear. So for the left-hand side, if I change x to minus 3, we get 4 plus 6. And the a and the b cancel out, and we're just left with c. So if x is minus 3, 2x plus 1 will be minus 5. And minus 3 plus 1, minus 2. So that means 10c equals 10. So c equals 1. To get a, we can sub in x equals minus a half. No need to do equating coefficients for this one, but that is a valid approach to finding the third value. Because we've got two of the values, we can just sort of equate coefficients to work out the third, but this seems slightly easier. Minus a half is slightly harder to work with, so 4 minus 2 times minus a half. 2 times minus a half is minus 1, so this is 4 plus 1. And then on the right-hand side, anything with the 2x plus 1 disappears, so we're just left with a times minus a half plus 1 is a half. And minus a half plus 3 is 5 over 2. Whoops. Divide both sides by 5, multiply both sides by 4, we get a equals 4. Okay, so we have found the values of a, b, and c. Now find the integral of f of x. Okay, so for part B, integral of f of x. So that's the integral of this fraction. So it's a over 2x minus 1. So it's 4 over 2x plus 1, sorry. Plus b, so that's plus minus 3 over x plus 1. Plus 1 over x plus 3. So that's the integral that we've been asked to do. So this, okay, so we need to do the chain rule backwards on this. So this will be 4 times log of 2x plus 1. But then we've got to divide by the derivative of this bracket. So that's divide by 2. So this is 4 over 2. I'll just leave it like that for now. And this one's just 3 log x plus 1. And log x plus 3. Now, the question just said to find the integral. So we don't need to simplify this. We can just leave it like that. However, I think I will simplify just because in the second part we're going to have to plug limits into this. So let's simplify it. So this becomes, well, the 2 in front becomes squared. It squares this. Let's do it in full. So this becomes log of 2x plus 1 squared minus log of x plus 1 cubed plus log of x plus 3 plus c, which I'm going to call log k. And then we just add these together. So that will be on the bottom of the denominator because it's a minus. Everything else will be on the top. So we'll just get log of 2x plus 1 squared times x plus 3 times k all over x plus 1 cubed. So for part C, we've just been asked to plug in the values 0 and 2 as the limits. So hopefully we got the first part right. We don't need the k because we find a definite integral with limits, so that the constant always cancels out. So I've forgotten it's between 0 and 2. So this will be log of. Okay, so we just got to be a little careful here. Plugging 2 in there, we get 5 squared times 5. So that's 125 over 3 cubed, which is 27. And we've got to take away log with 0 in there. So that would be 1 times 3 on the top and then 1 on the bottom. It's just log 3. So this becomes log 125 over 27 times 3. 81. Okay, for this one, it's another sort of like partial fractions questions, but this one's more complicated because it's an improper fraction. Improper means that the order of this polynomial on the top is bigger than the order of the polynomial on the bottom. We've got quadratic over linear, so it's improper. The usual approach for this is to use algebraic long division. I'm going to use an approach I call algebraic juggling. But if your algebraic long division gives you the same answer and you're happy with it, don't change, keep doing algebraic long division. But this is, this is interesting, even if you don't want to change the way you approach these. So in order to make algebraic juggling work, we need to rewrite that numerator, x squared plus 8x minus 3. We need to rewrite it with a factor of x plus 2, because that's going to cancel out. Now, it's not really a factor, because obviously it won't. We know that there's going to be a remainder from the question, so x plus 2 isn't actually a factor, but we're going to factorize it as much as we can. So we want to get an x squared and an 8x. So to get x squared, we need x in this bracket. Now to get the 8x, well, we've already got 2x, so we just need another 6. Now, if you multiply that out, you get x squared plus 8x, which is what we want. But you also get plus 12. But we don't want plus 12, we want minus 3. So we have to take away 15. Now, both of these fractions, I'm going to split it into two fractions. Both of these are over x plus 2. And look, we're already part way there. We wanted to get something over x plus 2, and we've got that. And we've also got the x plus 2 cancels here. So we're left with x plus 6 minus 15 over x plus 2. I did this question on TikTok, so one helpfully pointed out in the comments that I didn't actually answer the question because they said find the constants a, b, and c. Okay, so technically I have answered the question. I've found a, b, and c, but as the commenter on TikTok pointed out, it's good practice to just explicitly state the answer. So a equals 1, b equals 6, and c equals minus 15. So yeah, you wouldn't lose marks if you didn't write these, but it's always just good to be absolutely crystal clear. You know, if you got to think of the person marking the exam, if they're looking for 1, 6, and minus 15, if you've got it there written, all underlined, the marker can just tick it and move on, and that's what you want. You don't want the marker to have to stop, look at your work, and think. You know, you want them to just see the answer and mark it. So yeah, absolutely correct. Thank you for that feedback on the TikTok. Now for part B, we have to use this to get the exact value. Let's just check, because one thing exam boards like to do, but particularly at Excel, is to change this thing that we're integrating slightly from the thing that we wrote in partial fractions. Okay, so watch for that. They do that. Here they haven't, which is fantastic. It would just be some sort of multiple if they did change it. So we're integrating that between 0 and 6. So let's write this out. So for part B, we are integrating between 0 and 6, x plus 6 minus 15 over x plus 2. And now it's in partial fractions form. It's really easy to work out. It wants the answer written in the form a plus b log 2. Okay, so just keep that in mind. I've scrolled down, so I'm just keeping that there so I can check. And this is just straightforward standard integration. X squared over 2, 6x minus 15 log x plus 2 between 0 and 6. So if x equals 6, 6 squared over 2 is 18 plus 6 times 6. And then that's going to be log 8, isn't it? So this will be minus 15 log 8. And then we've got to take away what we get when we sub 0 in there. So 0 squared over 2 is 0, plus 6 times 0 is 0. But then we're left with minus. So we're taking away minus 15 log, 15 log 2. Okay. So it wants the answer a plus b log 2. We can do that. Equals 54. We want both logs to be in terms of log 2, so we can rewrite this as log of 2 cubed. So this becomes 54 minus the cubed will just come in front and multiply. So we get minus 45 log 2 plus 15 log 2. And that gives us a final answer of 54 minus 30 log 2. Okay, this one is just about whether you understand the formal definition of integration. So what we need to do is convert this sum, which is like a sum of rectangles, but we are making the width of the rectangles tend to 0. Another way of saying that is that we are integrating between 4 and 9. This integration symbol is basically shorthand for all of that. Yeah. And we're integrating x to the half and change the delta x to dx. So this just becomes x to the 3 over 2, add 1 to the power, divide by that new power, so it becomes 2/3 between 4 and 9. Sub in the 9, we get 2/3 times, okay, so square root of 9 is 3, then cube, that is 27. And we're taking away 2/3 times 4 square rooted, then cubed, so that's 8, which is 2/3 times 27 minus 8. 2/3 times 19. Okay. Which is 38 over 3. Another slightly weird question you see come up every now and again. They've not asked us to do the integral. They've asked us to show that the integral is independent of k. So the main thing here is just not be freaked out by the fact that they're asking is independent of k. All you need to do is do this integral, and then you should see that the final answer doesn't have a k in it. So we are doing the integral from k to 3k of, let's take that 2 out and just rewrite this as, it's just going to be a log, isn't it? Now let's just leave it then. We'll just leave it as is. So this becomes 2/3 times the log of 3x minus k. And that's between k and 3k. So let's sub in the 3k. We end up with 2/3 log of 9k minus k. That's 8k. And then we take away 2/3 times log of 3k minus k, which is 2k. So that becomes 2/3 log of, actually, since we're showing this, let's stick in an extra step. Just so that we can be clear why we're doing this. So now we get 8k over 2k. And here is where the k's disappear. So this just becomes 2/3 log 4, which is independent of k. Good. You should say that at the end because you are answering the question then. Part B. Show that this integral is inversely proportional to k. So it looks really similar to the integral we've just done, except it's not, because we've got a squared on the bottom there. So this will not use logs. So for this one, let's take that factor of 2 out, which is what I was thinking of doing last time. Again, we're doing it between k and 2k. This time we treat it as a bracket to a negative power. Now, because inside that bracket, this is just linear, we can just use the chain rule backwards here. It's only when that bracket has got more complex things in it than a linear expression that we can't, we can't do this by inspection. So this will become 2 times, okay, so we add 1 to the power. Oops. Divide by the new power, which is -1. And divide by the derivative of the bracket. So when you differentiate 2x minus k, you get 2. So this becomes 1 over 2. And actually, that cancels with the 2 that's in front. So let's just rewrite this as -1 over 2x minus k between k and 2k. So plug in 2k, we get -1 over 4k minus k. And we've got to subtract what we get when we sub in k. So this will be add 1 over 2k minus k. Add those two fractions, we get 3 over 3k minus 1 over 3k, which is 2 over 3k. 2 over 3k equals 2/3 over k, so is inversely proportional to k. Okay, I think I've put in one question about the trapezium rule. It's first part is just using the formula for trapezium rule. They've given you all the values, so you don't need to worry about the accuracy of your values or anything. A. Well, let's just double check that what they're asking us to do is just straightforwardly what is in the table. So the table gives values for root x plus 1 over x. That is what we're integrating, and it's between 0.5 and 2.5. So yeah, that table is everything we need. So using the formula, which is half h times y naught plus yn plus 2 times all the others. So that's the formula. It is in the formula book, so if you don't remember it, you will be forgiven for that. So this h is the gap between each strip, so it goes up in 0.5, so half times 0.5 is a quarter. Y naught and yn are the ends, like the beginning and the end, the ends. So it's not, whoops, 0.5774 plus 0.8452 plus 2 times all the others. So as far as showing you working goes, this line that I'm writing out now is all the working you need to get full marks. I have seen people worried that just going from this statement to the final answer will lose them marks because they haven't shown all their working. This question is done on the calculator, so it's plugging numbers into a formula and then correctly using the formula. So you should show this line here where we've put everything in the formula because it shows what we're doing, but then we could just jump straight to the answer. So I'm just going to tap this into the calculator. Okay, I've done that now. The calculator is saying 1.5. How 3 significant figures? So to 3 significant figures, it's 1.50. Okay, now for part B. Using your answer to part A, deduce an estimate for this thing. So what we need to do is think about how this is related to that. Well, what's happened is there's a 9 in there, isn't there? Yeah. So if I take that out as a common factor, it'll become 3 times the integral between 0.5 and 2.5 of all of this. Yeah, I've taken out a root 9. So it should be roughly 3 times bigger. So for part B, we get 3 times 1.50, which is, I'm using the full version so that I don't get any rounding errors, 4.51. But yeah. C. Okay. Comment on the accuracy of your answer to part B. So the answer was actually 4.535. So how far away were we? So we got 4.51. So that's 4.535 minus 4.51. So it's an error of 0.025. So what do we say here? Well, it's a good estimate. Correct to 1 decimal place. I don't know if it wants the percentage error. I don't think they do, but that's 0.025 out of the original value, which is 0.6% accurate error. So there we go. They didn't ask for the percentage error, so you don't need it, but that is what they ask. I would say it's a good estimate, correct to 1 decimal place. Since it's just asking for a comment on the accuracy and it's only worth 1 mark, that's why I wouldn't bother talking about the percentage error. Okay. Okay. So this is a unusual one in that they've given us an equation to integrate, but they haven't told us what everything is. We've got a P and a Q in here. But we've been given important information. We've been given that we cross through that point and we've got 2 vertical asymptotes. Now, explain why you can deduce that Q equals 4. So this is because of the asymptotes. The asymptotes, remember, are vertical asymptotes are values that X cannot take. It's an asymptote, meaning it never actually equals that. So the asymptotes come from values that don't exist. So if we made X equal to -3, that would mean we're dividing by 0. Yeah. So if the other asymptote is X equals 2, well, that means that in this bracket, we need X equals 2 to give us 0. So 2x minus q equals 0 when x equals 2. So that means q is 4. Okay. Show that p is 15. So for this, we're going to use the fact that 3.5 lies on the line. So that means 1/2 equals p minus 3x. Sorry, what's x? We've got a value for x, it's 3. 3 times 3. Over, right, we know q is 4, so when we sub in 3 for x, we get 6 minus 4. And then x plus 3, so this means that 1/2 equals p minus 9 over 12. So 12 equals 2p minus 18. 2p equals 30. So p is 15. Okay, so now for part B. We've got the curve here, and we're looking at this part, this shaded region here. Show the exact value of the area, and this is 8 marks. Okay, so there's going to be a lot of work here. We need to know what this value is in order to find where we're integrating between. So let's have a look at part B. So in order to find where it crosses the x-axis, we make y equal to 0. And actually, let's write out what y is, because we know P and Q now. So it's 15 minus 3x over 2x minus q, and q is 4. That's annoying because there's a common factor of 2 there that should really be taken out. Okay. So when y equals 0, that means 15 minus 3x equals 0. So 3x equals 15. So x equals 5. So that means the area R is equal to the integral between x equals 3 and 5 of 15 minus 3x over. Okay. So this will be done by partial fractions. So 15 minus 3x over all this equals a over 2x minus 4 plus b over x plus 3. Make that more obviously a minus sign. So multiply up by the denominator, we get a times x plus 3 plus b times 2x minus 4. So let's let x equal minus 3. So we're left with 15 plus 9, which is 24, equals b times 2x minus 4. So that's minus 6 minus 4. Although actually we're not wanting a decimal as our answer, are we? We're wanting a log. So we probably want this as a fraction. Yeah, 24 over 10 is 12 over 5. And then let's make x equal minus 2. Sorry, 2. And then 15 minus 3x becomes 9. A times x plus 3 becomes 5a. So a equals 9/5. Okay, so now, oops, I need more space. A equaled 9/5, didn't it? So the integral that we want then is still the integral between 3 and 5 of a over 2x minus 4 plus b over x plus 3. So this becomes, okay, so we've got a 9/5, and we're also going to have to divide by 2. Okay, so it'll be 9/10 log 2x minus 4. Take away 12/5 log x plus 3 between 3 and 15. Sorry, 3 and 5. Okay, so just got to be a little careful here. Sub in the 5, we get 9/10 log 2 times 5 minus 4 is 6. Take away 12/5 log 5 in there gives us log 8. We've got to take away what we get when we sub in log 3. So that's 9/10 log 2 times 3 minus 4 is 2. Minus 12/5 log 3 plus 3. So those log, this will be, what have we got? 9/10 log 6. We've got a minus minus there, so this is plus 12/5 log 6. Minus 12/5 log, and 8 is 2 cubed. Minus 9/10 log 2. Okay, so this is, we've got 9/10 plus 12/5, which is 33. 24/10, 24 add 9 is 33. Now, log 6 can be written as 3 times 2. Log 3 times 2. Minus, this becomes 36 over 5 log 2. So this becomes 33 over 10 log 3 plus 33 over 10 log 2. Minus 36 over 5. Minus 9/10 is minus 81/10. So finally we get 33 over 10 log 3 plus minus, so it's 33 over 10 minus 81 over 10. So minus 48 over 10. Okay, there we go. Okay, another final question now. It's each part you'll see is quite straightforward, but it's there's a lot of comprehension needed here. So let's take a look. The region R1 shown is bounded by the curve and the negative x-axis. Show that the exact area of R1 is 20 over 3. So in order to find R1, we need to integrate the function, don't we? So we're integrating x. This is the function that we're integrating, sorry. And we need to find the limits. Now, that's relatively easy because this is all factorized. So we know that the roots, the points where the curve touches the x-axis are the roots to this equaling 0. So that's at 0, at minus 2, and at 4. So the one we're interested in there is minus 2, 0. Okay, so that is the calculation to find R1. Now, in order to do this, we need to multiply out everything there. So let's just do that. So this becomes, if I multiply out the quadratic, these two brackets first, we get x squared minus 4x plus 2x and minus 8. But everything's multiplied by x, so all of these powers go up by 1. So this becomes x to the 4 over 4 minus 2/3 x cubed minus 4x squared. You sub in 0 for that, you get 0, which is quite nice. And then we've got to subtract what we get when we sub in minus 2. So that will be 4. Minus 2 cubed is minus 8 times 2/3. So that'll be plus 16/3. And then minus 2 squared is 4, so this becomes minus 16. Which is 16 over 3. Sorry, minus 16 over 3. We've got 4 minus 16, so plus 12. So that's 36 over 3 minus 16 over 3, which is 20 over 3, as required. So in part B, we're given the area R1 equals R2. Now that means, well, we know what R1 is. R1 is 20 over 3. R2, well, it's the integral between 0 and B of, everything we did earlier. The thing is, because this is under the x-axis, because R2 is under the x-axis, this integral is going to be negative, right? So that means it will equal minus 20/3. So we need a minus there. Now, to solve this, it's relatively straightforward because we've already done most of the work. This is what we get when we integrate the right-hand side. So that means minus 20 over 3 will equal... So it's going to be this, but with the limits now being 0 and b. So we sub b in there. We get b to the 4 over 4 minus 2/3 b cubed minus 4 times b squared. Okay, let's multiply both sides by 12 then. We get minus 80 equals 3b to the 4 minus 8b to the 3. 4 times 12 is 48. So we get, when that equals 0, we've got 3b to the 4 minus 8b cubed minus 48b squared plus 80. Now, to show that this is the same as this equation, let's have a look at that one and multiply it out. So if we multiply this out, that first bracket becomes b squared plus 4b plus 4. If you're more comfortable just expanding all that out and then simplifying, that's fine. I'm going to just try and just verify that I've got the right answer here. So we want to have 3b to the 4. We've got b squared times 3b squared, which is 3b to the 4, which is great. Now the b cubed terms, we've got minus 20 plus 12, which is minus 8, so that's good. The x squared, b squared is, we've got 20 minus 80, so that's minus 60 plus 12. Minus 60 plus 12 is minus 48. And then we've got plus 80. So that verifies they are both the same. Yeah, that thing is the same as this. Okay. So now for part C. The roots of the equation, this right-hand side, are given to 3dp. The value of b, therefore, is 1.225 to 3dp. Explain with the aid of a diagram the significance of the root 5.442. So let's sort of carry on that graph. So the significance of the other value, so we've got, this is R1. And I'm going to call this R2A and R2B. And this point here is the root 5.442. Okay, so B equals 5.442 is such that R2B minus R2A equals R2. So when you integrate between that upper limit 5.442 and 0, you end up with the same answer, but you don't get it in the same way. You get the same answer because this positive area is sort of cancelled out by that. Yeah, it'll equal minus R2 as well because we want it to be a negative area. Okay, thank you for sticking with us. That last one was a bit tricky.